Lavender's blue, dilly dilly, lavender's green. When I am king, dilly dilly, you shall be queen. Oh, that looks perfect. Oh, hello. It's a most splendid cup of tea. And what better thing to do when you're having a cup of tea than further your knowledge of science? Now, I've been referencing this cutting edge encyclopedia about one of my favorite topics. No, not flying an aeroplane, but something even more important, and that is, of course, the weather. And as you can see from this encyclopedia from 1961, it says weather is the state of the atmosphere. It includes temperature, barometric pressure, humidity, cloudiness or fogginess. We have plenty of that here in London. The direction and the speed of the wind, the amount of sunlight received, and the amount of rain or snow that falls. Weather is the one thing you can always talk about. During those periods of time when you have nothing better to say, you have the weather. And that's why I enjoy it so much. So let's dive into it, shall we? Now, as you can see from these cutting-edge graphics, we get back to that common theme, and that is called convection. Most weather patterns relate directly to convection in the atmosphere. And as you can see from this very recently drawn pictures, that the warm air rises into the air because it's less dense and comes plunging back down to earth because it's cooler and denser. All of these graphics show you exactly what happens with convection in the atmosphere. And we have discussed sea breezes with cool air coming in over the water towards the land during the day, and the process flips around at night where the cool air blows out over the ocean, rises up to the moon and drops back down again in what we call a land breeze. But let's not spend too much time with convection. Let's move ahead. Now, oh, look at this. Look at the fronts. There's a cold front, an amazing diagram, and a warm front. I like the bathtub pictures here. Okay, so what happened today in our weather? Well, as you can probably recall, we had some nasty thunderstorms move into the area. And as you may recall from class, we had a cold front. And when a cold front comes through, as we described earlier, the cold air pushes beneath the warm air. The warm air then rises and cloud formation occurs. And with cloud formation, we have condensation. And condensation, of course, creates rain. And in today's case, we had some instability causing lightning. So, weather's not as complicated as you may think. Now, what is a warm front? If a cold front wedges beneath warm and pushes the warm air up, causing quick condensation, a warm front comes in a bit slower from the opposite direction, and it rises above an existing cold air mass. And as it does, clouds do form. However, no thunderstorms are present because condensation doesn't occur as it does with a cold front, and therefore you might get some drizzle, a steady rain if you will, but nothing major, no thunderstorms. Now, we talked about high pressure versus low pressure. Maybe some of you recall that. With high pressure, air is denser and therefore sinks. And if air is sinking, we know there's one thing it can't cause, and that, splendid. With high pressure air sinking, we can't have the creation of clouds. And so generally speaking, with high pressure, we have beautiful weather, which again, we don't get a lot of it in my country. Now with low pressure, air is less dense and therefore it rises very so slowly and clouds are allowed to form. And that's why with low pressure, we tend to have weather that's a bit cloudy, possibly rainy. High pressure generally means fair weather because again, the clouds can't form. So let's review. High pressure, fair weather. Low pressure, cloudy weather. Cold fronts wedge beneath the warm. The warm air rises to the sky and causes rapid cloud development and condensation, and sometimes thunderstorms or the dreaded tornadoes. Now, with a warm front, it's an opposite process. The warm air lifts above the cold air mass. Clouds can form, maybe a steady rain, a bit of a steady rain, but nothing major. Now that leaves us with two more fronts, and that is the stationary front. Splendid, which as the name implies is a front, kind of a hybrid if you will, of a cold and a warm front. The cold front, the warm front, they meet, and it's a stalemate, like the badminton game I played last week with my mates. the front has nowhere to go. It just basically parks over the region. It doesn't move, and so the weather stays the same for sometimes hours, sometimes days. And finally, our old friend, the occluded front. Now, an occluded front means a cold air mass catches up with an existing cool air mass and overtakes it, like in a Formula One race, if you will. And as the cold air overcomes the cool air, oftentimes you have warm air trapped in between. And with this can be cloud development, a steady rain, and a great day to sit around and drink tea. So, it's wonderful. That is a quick wrap-up of weather for your STAAR test preparation. Good evening, all.